This is an AQA GCSE chemistry question, and it's from the topic Quantitative Chemistry. It's 8 marks. I'm going to recommend that you try each section, pausing as you get to it, and then review your answers later. So here's part A, part B, part C, part D, part E, part F, and part G. So if you've had a chance to try all of those, if you move on, we'll have a look at the review. So you've been given a method here. A student investigated the reaction between lumps of calcium carbonate and dilute hydrochloric acid. The method: 100 cm cubed of acid in a conical flask, place it on a balance, add 2 grams of calcium carbonate lumps to the conical flask, wait until it stops reacting, record the decrease in mass, repeat those steps 3 more times. We're given an equation, and then you notice that there is a state symbol missing. We need to know the state symbol for calcium carbonate. We've been told all of the others. HCl is aqueous, calcium chloride is aqueous. That means they're both dissolved in water. Carbon dioxide is gaseous, and H2O is a liquid. But what would calcium carbonate be? Well, there is a big clue in the question if you are unsure, because it tells you that there are calcium carbonate lumps. That tells us that it's solid. Moving on to part B, and we've got some student results. Why does the mass of the conical flask and contents decrease during the reaction? Well, it does relate back to that equation that we've just looked at. We made CO2, CO2 is a gas, and the gas escaped into the air. So, although it still exists, it wasn't there on the balance to be measured. So a gas escapes. We move on to part C, and we have got the results here, results 1 through to 4, and we want to know what the range of the 4 results in the table is. This is a really straightforward question. You find the lowest, you find the highest, and that is your range. So result 4, 0.47, result 3, 0.86 are the outliers within my range. So there's my mark. And then we go ahead, we're calculating the mean decrease in mass of the conical flask and contents, not including the anomalous result. And I'm going to highlight that because it's something that's often missed. We don't include all of them, and if we were to identify what the anomalous result would be, 0.47 is far, far away from all 3 of the others. So I'm now going to take my average of the 3 that I am including, 0.84 plus 0.79 plus 0.86, and divide that by 3 because there are 3 values included. And that takes me to a mean decrease in mass of 0.83 grams. If I move on, I've got a graph here. What type of variable is the mass of calcium carbonate? Well, let's have a look again. The teacher used different masses of calcium carbonate. So from there, that tells us that it's the independent variable. The independent variable is the thing we choose to change. The dependent variable is what we measure as a result of that change. And the control variables are the things we try to keep the same so that only the independent variable will have an influence on the dependent variable. Still with the graph, use the graph to answer parts F and G. Complete the sentence. As the mass of calcium carbonate used increases, the decrease in mass of the conical flask and contents. And what we're looking for here is it increases. There is a proportionality between the two. As the x-axis value increases, so does the y. And then finally, what is the decrease in mass when a 3 gram sample of calcium carbonate is used? Now you might be tempted to do this by eye. I would always recommend take out a ruler and put the lines in, as you can see that I've done here. And what you can very clearly see then is that at 3 grams we would expect a loss of mass of 1.3 grams. That takes us to the end of the question. Thank you for listening.